Hey here, baby. Hey, it's Dr. Madness with more Chemistry Madness. We're talking about equilibrium constants, K, and we're saying, hey, what about this Q thing? Q is what we call the reaction quotient. It's calculated just like an equilibrium constant, products divided by the reactants. But here's a gig. If you're not at equilibrium, you can't have an equilibrium constant. You need to call it something else for lack of anything really sexy and interesting. We just call it Q. It's the quotient. It's calculated the exact same way. Well, for this example, I got a reaction here of NO to N2 and O2 with a K of 2400. Alrighty. Well, down here, I'm going to ask you a question one about it, question two about it, giving you reaction conditions. Are we at equilibrium? If we're not at equilibrium, which way is that puppy shifting till it's attaining equilibrium? Equilibrium is preferred state. It's going to shift and get there. Alrighty, so let's just dive right into it. For both of them, we're going to have the same thing. That's why I gave you the exact same reaction. And we're going to say Q because if we're not equilibrium, we can't call K. So Q is N2O2 over NO squared. Don't forget the square. So in number one, we're given molarities. I gave you molarities. So you can plug those numbers right in there. 0.024 for N2, 2 for N, for NO, 2.0 for N2, 2.6 for O2. Crank the math, you get 9,030. I know it's an extra sig fig. Just doing it. And number two over there, I didn't give you molarities, I gave you moles. So now you got to do moles divided by liters to get molarity. Well, NO is 6 moles per 2 liters, so that's going to be 3.0. N2 is 0.2, so that'll be 0.1 we divide by 2. O2 is 0.4, so that'll be 0.2. We're dividing by 2 because the volume was 2. When you do that math, you get 0.0022. Well, now we got to say, are we at equilibrium or not? Well, K is 2400. If we were at equilibrium, it would have been 2400. So neither one's 2400. We're not at equilibrium. The question is, where are we? Well, K is products over reactants. And the thing that you have to recall is, hey, if I have more of something, rates speed up. Equilibrium, we have the forward rate and the reverse rate equal. If we're not at equilibrium, which we aren't, one of them is faster, one of them is slower. Question is, which one? Well, in number one over here on the left, this is going to be number one. This is number two. And number one on the left, Q is greater than K. So that means the products are greater than the reactants, which means we have more products than we need at equilibrium. Okay? If we had the right amount of products to achieve equilibrium, we would have been at equilibrium. So Q is greater than K, we have more products. On the right over here, Q is less than K, so we have more reactants. More increases rate. So on the left, we have more products. Products are chewed up in the reverse reaction. So if we have more products, that's making the reverse reaction faster than it should be if we're at equilibrium. So that means instead of being happily equal, the reverse is going to be faster. So the reverse is going to be our big fat arrow. Okay, and that means it looks like we're running to the left. And number two, we have more reactants. Reactants are chewed up and spit out in that forward reaction. So the forward is faster. So instead of being equal, the forward's faster. So now that's the big fat puppy on top, little guy on the bottom. Forward's faster. That means we're predominantly running to the right. And so we're going to shift right. If you don't like thinking, don't want to think about this stuff, the hint is always given to you. That little puppy there, that little puppy there, those pointers always point in the wrong direction. It's the other way that the reaction is shifting. Hope you enjoy it. Have a good time.